fly. But without further ado, I'm going to turn over to Doug Sandilands with SR3 Sea Life Response and Rehabilitation and Research. And he's going to kick off with the first presentation this morning. Doug, I turn it to you. And Doug, if you happen to be speaking, you are still muted.
But we can see your screen.
Hey, Doug, I think you are now unmuted. Let us know if you can speak.
Okay, can you hear me?
Yes, I can hear you.
Okay, good stuff. My panel disappeared with my ability to to do all those things once I did full screen. Anyways, well, thank you very much for having me. I really appreciate the opportunity to talk about large whale entanglement response and the information collected during response. I'd like to, well, I work for Sea Life Response Rehab and Research. I've been working on large whale entanglements for about 15 years now in Canada, the east coast of the US, and then for 3 years here on the west coast. I'd like to acknowledge my collaborators, which are John Kalmakidis, Kirsten Flynn, and Jen Takavari on this. All the images taken in this presentation are taken under NOAA Marine Mammal Health and Stranding Response permits and were captured by SR3 or Cascadia unless otherwise noted. So managers rely on good information to make decisions on managing fisheries that entangle large whales, but entanglements are actually rarely observed, rarely reported, and even more rarely well documented. So entanglement reports provide a rare opportunity to learn directly about the problem of entanglements, but it's really if a trained team can respond. The information we collect during those responses include things like species ID, individual of the whale, gear type involved, entanglement configuration, the injuries on the whale, and the body condition of the whale. Further to that, scar studies collected during population studies can actually provide context for understanding the extent of the problem in a population and what proportion of entanglements and mortalities are observed. So the typical documentation we get from a public report is usually pretty minimal. For confirmed versus unconfirmed, about somewhere between 15 to 20% of our reports are not confirmed, and so these come from shore observers, whale watch passengers, and sport fishermen, and so on. But they actually come with a fairly limited documentation, but very often we're pretty sure they are actually entangled whales. For the confirmed reports, we tend to be able to see gear on the whale towing the gear through the water, but there's a pretty good lack of information more generally about how the whale is entangled, since we have limited documentation. So the best case documentation from a public report usually comes from a whale watcher or trained mariner. And for these, we can actually see the gear on the whale towing the gear through the water. We might even have a photo ID to be able to match the whale to a catalog. And we still only get about maybe 5 to 10 images from these reports, and so much remains unknown about the entanglement. On the East Coast and in Hawaii, they looked at the reliability of entanglement reporting sources. Inexperienced reporters misrepresented about 55% of the information about the entanglement if an entanglement response team was able to follow up. Fishermen were quite a bit more reliable, with misreporting about 41%, and the whale watch community about 20 or about 13%. So if either an entanglement is reported and the mariner stays with the whale until a trained response team can get there, or an entangled whale is found during research efforts with a team capable of responding or standing by, then we have really the rare opportunity to learn about the problem of entanglement. And I just want to note that entanglement response is inherently dangerous and should not be attempted by untrained responders, and even collecting documentation should be done from a distance. It's important to note that reports of entanglements are not equivalent to the rates of entanglement. Reports are really a function of the number of entangled whales, the number of potential observers with knowledge of how to report and a willingness to report, a network able to receive these reports, and then these observers have to find the entangled whale and report it. SCAR studies provide a little bit more insight into the size of the problem, and through disentanglement and large whale research efforts, we can look at the whales that we know as individuals and see the wounds they get during entanglements and watch those resolve through time. And because we know the whales as individuals, we can look at the proportion of the population that has entanglement scars and the annual acquisition of new scars. And there are efforts away, this research has been ongoing on the East Coast for quite a while, and efforts are underway here with Cascadia and partners to understand for this more for the West Coast. So just to look at the East Coast, the big yellow circle is the whole Gulf of Maine population. That's about 1,000 whales. About 70% of those whales have been entangled at least once based on SCAR studies. That's the big brown circle. We know that about 17% of Gulf of Maine humpback whales get a new scar from entanglement annually, and about 2 to 4% of those whales die each year due to entanglement. But we know because how many reports we get that only about 10% of those reports come from the whales that get entangled annually, and about 50% of those team is able to get to on the East Coast, and if they can get to the whale, about 90% success rate of disentangling the whale. So without SCAR studies, what we understand is really very little. It's the whales reported entangled annually and the observed mortality, and a lot is left unknown. On the West Coast, there really is no estimate of what proportion of entanglements are reported. There's no estimate of the actual mortality. We have only observed deaths, and then for the serious injury and mortality determination, the injuries that are likely to cause death. Between 2004 and 2007, about a third to 2/5 of West Coast humpbacks showed entanglement wounds. We had fewer than 6 reports in each of those years. Another way to look at this is on the East Coast for entanglement response. We add telemetry to the whales entangling gear if we aren't able to disentangle it on the first day, and so 25 different whales were attached telemetry tags to them for a total of 203 days that these whales towed this gear through pretty busy areas of the East Coast, and all these entangled and tagged whales, there was only a single report of all the whales. So it gives you a sense of just how hard it is to find an entangled whale. So the opportunity for documentation during a large whale entanglement response comes from the document we collect mainly so we have a good understanding of how to disentangle the whale. We use a pole cam alongside the whale. We use a pole cam while being towed behind the whale and have a helmet cam going all the time. And we also use a handheld cam often behind the whale. And then our support board has an SLR camera on it. That camera will collect about 1,000 photos during the day, up to several hours of helmet cam footage, the underwater pole cam footage. We also have the gear we removed from the whale and skin and blubber samples, which all give us a better sense of what's going on. We make a very strong effort to take fluke shots, and often entangled whales don't bring their flukes to the surface. And so we'll use a GoPro on a pole to try and capture that so that we can match that to an individual. And Jen Tackberry is going to talk about what we can do with that if we are able to collect it. It's worth noting that between 82 and 2017, that about 70% of the IDs of entangles that we have were collected by trained responders. So even though we have relatively few IDs from the total ensemble of entangled whales, where we are able to match it, that largely comes from entanglement responses. We also look at body condition. Looking from directly behind the whale, you can see the loss of blubber. And alongside, you can look at the skin condition, and proliferation of cyamids is a really good indication that the whale is not in good shape. We also collect underwater documentation and can look at the injuries there. Things from blood being cut off in the flukes to simple abrasions to near amputations and deeply embedded line. One of the main goals is to look at entanglement configurations so that we can make decisions on how best to remove all the entangling gear. But afterwards, when we have that documentation, it really gives us a good sense of how the whale may have been entangled. We can look at the gear that we collected and then match that up. In terms of behavior and energy level, we also collect documentation to look at that, which gives an idea about the whale's condition. And we also collect the gear, which allows us to identify the gear to a fishery. If you just are looking at gear being towed through the water, it's really hard to identify that. But with gear in hand, you can learn a lot more. Information from each response is recorded in a database the IWC designed. This is some example of the gear that we've removed from an entangled whale, and then looking at it up close to see how the whale may have encountered that gear and in what part of the gear set it became entangled. So management science uses this data from entanglement response to look at serious injury and mortality determination, to identify the whale to a distinct population segment. Survival analysis, if we're able to get a photo ID, we can look at its sighting history before and after. Assigning a case to a fishery through the list of serious fisheries and serious injury and mortality, and collecting gear allows for interview with the fishermen, which is what we're going to talk about this afternoon, and I think is one of the big benefits to this information. So just as a summary, reports are not equal to rates of entanglements. Entanglements are severely underreported and not necessarily representative of the total number of entanglements occurring. Large whale population studies collecting images of entanglement scarring will provide a clear understanding of the total number of whale entanglements occurring. And really, without a response from a trained team, there's very little that we're able to learn about the entanglement. And this information cannot be collected in any other way. It's really important to think of entanglement response as not just saving the lives of individuals, but it's the opportunity to gain knowledge that can prevent entanglements in the future and save many more whales. So I'd just like to thank all the individuals and organizations conducting and supporting large whale entanglement response on the West Coast, which is largely volunteer and side projects for a lot of these people. So thank you.
Great, thanks, Doug. Really appreciate that. I think we're actually a little bit ahead of schedule, so not to jeopardize that, but I wonder if there's any clarifying, if we have a couple time for maybe one or two clarifying questions, I would open up the floor. Just looking at the Q&A box, I do not see anything in there now, but I'll pause for a minute, and if there's any clarifying questions for Doug, if you'd like to raise your hand or put it in the chat box, we can try to answer that.
Stop me from sharing. I might be able to turn on my video and other things. That's all disappeared now until I get sharing. Thank you.
Yeah, so attendees, you're looking for those three dots for the Q&A.
Okay, and I see Larry has his hand up. So Larry, if you want to unmute yourself, go ahead.
Yeah, thank you. So Doug, I'm curious to know, how successful you have been in potentially assigning the DPS of entangled whales by the photo IDs that you have been able to do, and also, that would be relative to entanglements with mortality and stranding, and specifically as maybe a piece to look at a small chunk of the 5 confirmed entanglements in Washington with humpbacks 2013 to 2018. Could you identify any of those 5 confirmed DPS sources?
Well, I don't want to steal Jen's glory. That's going to be basically a lot of her talk in the next talk. But we are getting better at collecting photo IDs, and until the last 5 or so years, there was relatively few who had photo IDs before, but it's become a real priority. So we're getting better, and I'll let Jen answer that in her presentation, the rest of your question.
Thank you.
Great, thank you, Larry. I do not see any other hand raised, and sounds like that's a good segue into Jen's talk. So again, appreciate your presentation, Doug. And I forgot to mention, remind our presenters at the beginning, I know I sent out an email end of last week. So there will be a warning at 8 minutes, a chime, and then a bite bell at your end of your presentation. So if you can hear that, it kind of comes through, it's a little bit garbled, but that's what that cue is. So I just want to introduce Jen Packaberry, Cascadia Research, and I will turn it over to you, Jen. Thank you.
Hi, I have not gotten the invite to, oh, there we go. Okay, sorry. All right, can everyone see my screen?
Yes,
Yes,
looks
Okay.
good.
So just to introduce myself, I'm a research biologist and level 4 responder for Cascadia. I've worked on about 60 to 70 cases, both on the East Coast and the West Coast and some in Canada. So I've been working on this type of data for the past 10 years. So this is, I could talk about it forever. But with that and the short period of time, I'll get started. And I'll be talking about the work my colleagues and I at Cascadia Research have done to examine the resites and survival of entangled humpbacks and other large whales in the West Coast region using entanglement data and images provided by NOAA to compare to Cascadia's long-term photo ID catalogs and sighting database. Since I have a lot to share in a short period of time, I'm just going to jump into some of the results based on the information we can gather when working with images collected from trained responders. And that includes whale watching companies, researchers, and response teams, so level 2 or up. It's rare for us to get good enough quality images from the general public in order to use them for photo ID. So from 1982 through 2019, we had 217 confirmed entanglement cases along the West Coast. Of those, we had 53, which had good enough quality images to be compared to Cascadia's catalog. 35 of those had sightings outside of their entanglement year. We added the remainder to the catalog to elicit resites. Now, for most of my talk, I'll be talking about a subset of this data, just cases from 82 to 2017. And that's because we were looking for resites, so we needed a few opportunity years of data to look at their pre-entanglement or post-entanglement sightings. Before I get into that, just some of the results based on the 53 cases. We do know the sex of 8 of them, the exact age of 6 of them, and the known DPS based on photo IDs. Those are photos taken in the breeding grounds for 15 of them. So 6 of them were to Central America, 9 to Mexico, none to Hawaii. And using genetics, we could increase the Central American DPS to 8. Now, the challenges with photo ID is the fact, sort of like Doug mentioned, the whale has to be able to bring its fluke above the surface of the water. So a lot of this data is biased, and it is underrepresenting anchored whales, hogtied whales, or severely compromised whales. It's not until the more recent years that's more inclusive due to real-time reports and people standing by in order to get the response teams to get on scene and collect that underwater documentation that Doug was talking about. Life history data provides information about survival, site fidelity, and demographic information. So the photo in yellow is the whale during its entanglement year, and we compare that to the catalog, found that we do have pre-entanglement and post-entanglement sightings of that individual. Now, we could look at our 37 cases and just say, have we seen you after your entanglement or not, or compare it to the overall trends of the West Coast population. However, we do know there's different effort along the West Coast. So if you're a whale in Monterey Bay, you have a much higher chance of being seen in general than a whale off of Oregon or Washington, regardless of being entangled or not. So we did want to take that and also the time of year of the initial report into consideration. So we used control groups to compare to our entangled whales. So we based control groups on the location of the report. We broke the West Coast up into different zones, and wherever that entanglement occurred, that zone became the initial entanglement report zone. Then we could use all the whales seen within that zone within 3 months of the entanglement. So 45 days prior to 45 days after the entanglement to form our control groups. So for example, for this one case in Southern California, we took all the whales that were seen in that zone within 3 months of the entanglement. And then we could look at their post-entanglement year or after 2015 for this case, as well as their sightings pre-2015. With that data, we're able to determine that entangled whales are seen less often and are known to be alive for a smaller percentage of time than control whales. With that said, we looked at this a few different ways. So we looked at pooled data to look at the percentage of years seen, as well as the percentage of years known to be alive, as well as the percentage of whales seen each year. And each way we looked at the data, we came up with the same results. So I really could end the presentation right there and say that's what we found. But when looking at this, a few things piqued our interest that we wanted to look at a little further. So with the difference between the percentage of whales for the entangled whales and the control groups that were seen post-entanglement, we want to determine if this could be due to the fact that these whales are out of habitat or they don't belong to the West Coast population. We also wanted to look at the sightings pre-entanglement. So when we plotted the data, we were really surprised that very few of our entangled whales had ever been seen prior to their entanglement. And so once again, we want to see if this could be due to the fact that these aren't our whales or they're just out of habitat. And this is a very busy slide. And if I have time at the end, I can dive more into this a little more. But basically, we compared sightings within the West Coast region as well as to outside the West Coast region. And the lower resites of entangled whales is not because these are individuals from outside the West Coast region. So we supplemented the CRC catalog with happy whale to compare these animals to other foraging ground populations. Basically, is this a whale that had been seen in Alaska for 10 years? It showed off of the West Coast while entangled and then went back to Alaska. And that is not the case. None of our whales match to any other feeding ground. So these are our whales getting entangled and being seen in our neighborhood. We also found that entangled whales are more likely to be resighted post-entanglement when their initial report occurs in the same region where the entangling gear was set. Now, this is based on a very small sample size, and that's because less than half of the cases that we had that had photo IDs could be tied to a fishery or a location where that fishery set its gear. So a better marking system across multiple fisheries across the entire West Coast would help inform this data, and we could have better estimates. I also don't want you to confuse the distance between where the initial report came in and where the gear was set with duration. We have other matrix that can determine that, including photo ID, as to when the whale was last seen gear-free before it became entangled. Since we determined that these whales are not out of habitat and they are our whales, we want to explore what could explain the low resite or the low pre-site, pre-entanglement sighting of these entangled whales. And we found that entangled whales that have shorter sighting histories pre-entanglement than the control whales possibly is reflecting the fact that these are younger animals. So in this chart, we broke it down into both entangled whales and controlled whales that were never seen prior to their entanglement year, that were first seen only within 3 years of their entanglement or seen 4 or more years. And for a quick lesson in humpback biology, 5 is the minimum age of sexual maturity. So if you're 5 or older, you're considered mature. And if you look at this, the entangled whales are dominated by individuals that had never been seen before or that have short sighting histories, whereas the control groups are dominated by mature animals. On the East Coast, where they know a lot of the whales by since they were born, so they know their exact age, they found that animals that have shorter sighting histories are most likely juveniles. So compared to known age juveniles, based on their behavior, their recitability, also their mortality rates, they could determine that the short sighting histories could sort of be used as a proxy for age class. They also found on the East Coast that juveniles are more likely to become entangled than mature animals. So if we use our short sighting history as a proxy for age class, our results do agree with the East Coast data that animals with shorter sighting histories are more likely to become entangled than mature animals. But we want to make sure this wasn't due to a higher mortality rate of an age class if we're using these sighting history as a proxy for age class. And we found that although many of our whales are likely to be younger whales, the sighting history length does not account for the difference in resight rates between entangled whales and controlled whales. So if you look at this graph, we broke both the entangled whales in green and the control group in blue into shorter or longer sighting histories. And across the board, you can see regardless of the sighting history length or the proxy for age class, that entangled whales or fewer of the entangled whales are seen post-entanglement than the control group. So therefore, it's not because of mortality, a higher mortality rate, age class, or being out of habitat. Our entangled whales most likely aren't being seen because of their entanglement. So quickly, Dan's going to talk about the serious injury scores more so, but we found that the resight rates of our known or photographed animals post-entanglement generally do correlate with the initial serious injury score assigned by NOAA. So if you look at the yellow, those are animals that were classified as a non-serious injury, and over 70% of them were recited, which is pretty much even with our control group. And so that's great. And then when you look at as the score increases in severity, we see fewer and fewer of those animals. Unfortunately, the final score did not correlate as well with the initial score, but we need more analysis to determine, what's causing that disconnect. And just quickly with the gray and blue whales, there are a lot of gray whales that are reported or confirmed entangled. Very few of those cases have good enough images to be tied to photo ID, but when we do have that, we have been able to match most of them to the catalog. So 5 of the 7 gray whales that were matched belong to the PCFG population. The only 2 gray whales that have been recited were both PCFG animals. And unlike blues or humpbacks, gray whales have been documented with the same entanglement across multiple years. So we have had 1 gray whale that was entangled for at least 3 years. With blue whales, there are very few reports of entangled blue whales, but when we do have an ID, we have been able to match it. All 3 of those individuals had a sighting history of at least 20 years before their entanglement, and unfortunately, only 1 of those have been recited. There are gaps in our knowledge that can be filled with photo ID data, such as the lethal effects of entanglement, short and long-term effects of entanglement, as well as the influence of the time of year and the duration of the entanglement on survival. When we combine photo ID with a better marking system for gear, that can help highlight if certain gear types or modifications have a higher or lower survival rate than other types, and also what are the health effects or injuries caused by entanglements of different duration. With that, I just want to say thank you. We want to say thank you for NOAA and for everyone who has reported entanglement, who has stood by a whale till response team has arrived, and all the responders or trained folks that have taken images of these whales and collected data on the entanglement, and also the contributors to Cascadia's humpback catalog and Happy Whale. And just to give you a brief look, that over 450 different contributors to the catalog, and that just goes to show how much effort it takes to collect 40 plus years on a coastwide population. And with that, thank you.
Great, thank you, Jen. That certainly is a long list of contributors. I appreciate the presentation. Do you have a couple, I think we've got time, just keeping track of time here. We do have a couple clarifying questions from the attendee list. This question, what info do you need to estimate non-observed entanglement frequency?
For this, it would be most likely SCAR studies, and Doug can chime in as well. But basically, we have been able to determine that certain markings on the tail are caused by gear. They're not caused by behaviors down the breeding ground or anything like that. And that's based on East Coast data. And so by collecting tail stock images of basically healthy looking whales or any whales in the population, we can then get an estimate of how many whales have become entangled. And so Cascadia, they're in the process of submitting a manuscript or finishing a paper on basically entanglement scars across the entire West Coast population. Also, there's a new study that's starting that's focused more so in looking at individuals and how they accumulate scars over a certain number of years. So we'll have not only an idea of how the whole population is affected by entanglements, but also more on an individual level, how often a whale might become entangled throughout its life.
Great, thank you, Jen. I've got another question from the audience. This may be more directed at Doug, but Jen, if you can answer this. The question is, I'd like to know if a line taken off a whale, assuming we're in entanglement, once taken off the whale, is the line measured? This may be a question for Doug during the post-entanglement response.
You just broke up a little bit. You said, was it the question, would you like to know if the line is taken off the whale and measured?
Yeah, I think.
Yeah. So
I think once the entanglement response has arrived, once all the gear's taken off, how much of it's measured and documented?
Yeah, so we have a whole process of doing that, and we basically take all of the gear, lay it out, do a full measurement of the type of line, if there are any splices or knots or cuts that are made, and then also how it was most likely configured on the whale. And so we have, we're actually getting more and more gear sets on this coast, and we're actually trying to find a place that we can bring all the gear together and then have workshops and work with the different working groups to basically talk to the experts, the fishermen, to let them take a look at the gear and help us figure out some of the questions, especially when it relates to, you know, where line goes from floating line to sinking line to mutually buoyant line. But we measure it and take a ton of data on the types of gear that we take off the whales.
Great, appreciate that. I'm just keeping an eye on my chat boxes. I do not see any other questions right now. We're doing okay on time, but we'll go ahead and go to the next presentation, and then I think we'll probably have some time at the end here before we move into the panel discussion to see if any other questions have come from the audience. So I'm going to turn it over to Dan Lawson to take us into the next presentation.
Hi there. Just when you think you've had enough of me, here I come again. But actually very happy to be with you all today and to actually take off my MC hat and put on my day job hat, which is, you know, spending a lot of time, you know, looking at entanglement documentation and thinking about entanglements. So today I'm going to talk about some work we did really that came out of our conversations with the three states and our coordination, as Ryan mentioned, on their conservation planning and their needs to generate sort of a common understanding of what should we be anticipating from serious injury and mortality rates for entangled whales. You know, that's going to be a key step sort of, I think, throughout the conservation plan and incidental take permit process, as well as monitoring things as we go along. So this is something that, you know, I'd already been thinking about doing, and there are some other reasons in particular that I hope to highlight as we go through the talk. What I'm not going to do is be able to spend a lot of time talking about the actual serious injury and mortality determination and the process itself. For starters, you know, I don't make those assessments. Those are done by our scientists at the Southwest Fisheries Science Center, and you know, it in and of itself would probably take up the whole talk. So, really going to turn more to the results of the assessments, you know, that are done by that group. But I think I can give you a quick flavor in terms of, you know, serious injuries versus not serious injuries. If you look at the whale there on the left-hand side, that's a line that I think essentially just kind of stuck to the barnacle on the flipper. You know, that's the kind of injury that probably wouldn't rate as a serious injury, you know, compared to the whale on the left-hand side that's had a very constricting wrap, at least prior to this photo, around its fluke, and that's something that looks like you know, that fluke may not even survive, and certainly losing the fluke would be a very serious injury and almost sure death for the whales. Okay, anyway, next slide. First thing I want to touch on is just the general flow of information of how this serious injury and mortality gets done. You know, the reports come into our West Coast Region Marine Mammal Stranding Program. They activate the response community, and you know, that's when ideally, you know, we're getting, you know, lots of documentation of the entangled whale, you know, regardless of the outcome of the response. Fairly quickly, the West Coast Region sort of entanglement team, which there are a number of us who are involved, the folks from the stranding program, other folks that you know, are involved on the regulatory side, involved with, you know, fishing gear expertise and things of that nature. We get involved fairly quickly to try and determine what do we think was involved in this entanglement. Outreach immediately, you know, to state folks interested, communicating these results to the various working groups who are interested in entanglements, and then, you know, annually, you know, producing the West Coast Entanglement Summaries that I hope most of you have seen. This information is then provided to the Southwest Fisheries Science Center, and they conduct the serious injury and mortality assessment. Again, an annual update is provided in a technical memo each year. That's made available to the public for review, and ultimately, you know, those assessments end up in the Marine Mammal Stock Assessment Reports. So it's a pretty long flow of information. The criteria for serious injury are based from you know, national guidance, and they are based on data from known outcomes from previous entanglements, you know, as well as expert opinion. the definition of serious injury is one that's important. It really just means more likely than not to result in a mortality, or essentially any injury that presents a greater than a 50% chance of leading to death. So it's not necessary that we know for sure that any particular injury, does lead to a death. For the most part, we don't know the outcomes of entanglements, after we last see those whales. So it is not necessary to prove that in order to make a serious injury determination. Next slide. Before I talk about the results of the analysis that we did, I thought I'd set the stage a little bit for what I think we can do with this kind of information. For sure, we can and are providing the states an opportunity to know the expectations for future serious injury and mortality rates of entangled whales, that can be used in their conservation planning and can be used by all throughout this process. Another thing that they can be used for is, I say, preliminary expectations for entanglements as they occur to support in-season actions. In particular, I think about the California ramp program that is essentially reacting to entangled whales, as they happen, and knowledge of what we've seen in the past from serious injury and mortality rates can really be used in advance of being able to make that determination on the fly. There's typically on the order of about a 2-year lag before the serious injury and mortality assessment's made, from when these events happen. So needing to take actions in between, this is where you can look for some information to inform those actions. Or if folks, again, in advance of having serious injury and mortality estimates, they can use these assumptions in order to implement new management measures, to respond to events as they occur. I think the last two things on this list are what is really interesting to me to think about what we can do with our knowledge of previous serious injury and mortality rates. I think we can use these to monitor the effectiveness of any management measures that are measures or changes in fishing practices that are implemented. It's going to be very difficult to evaluate, as we introduce management measures, and maybe particularly, some on the gear side, are they effective or not at reducing entanglements? But we may see changes in the nature of the injuries and ultimately, how those injuries are assessed in terms of their relative impact to the population. We may be able to see that even in advance of being able to understand something along the lines of whether we've reduced entanglements or not. So I think monitoring this factor may allow us to see, are we doing good things? Are we being effective with our management measures, and or do we need to keep working? In addition, I think just an understanding of the relative serious injury and mortality associated with different gear configurations, can help us actually design new measures, based on the results of those assessments. Next slide. All right, so for the analysis itself, it's a pretty straightforward analysis. On the left-hand side, you can see the methodology here, and I won't spend much time going over it. Essentially, you just define the category of entanglements that you want to look at, and you can add up the assessed serious injury and mortality and derive a rate for that. So I'll focus just on giving some of the results here on the right-hand side. This data and information was sliced up just about any way you could possibly imagine, and there a large number of results that I could share. So I just wanted to select a few highlights of what we got. Jen touched on the notion of final serious injury and mortality rates compared to initial. Final, really referring to the sort of after any resites, after any human intervention, what's the last thing we know about the whale and the state of that injury that as we last knew it. So overall, for most all categories that we looked at, for all species, generally the serious injury mortality rates sort of fell between 0.6 and 0.8 per entanglement, centering on serious injury mortality rate of about 0.7. It was interesting that the rate was a little bit lower for humpback whales than it was for gray and blue whales, and that really got me to thinking a little bit about blue whales. And why we would see potentially, slightly more serious injuries documented from the whale entanglements from blue whales. At least one idea that I came up with is if blue whales release from entanglements, generally more easily because of their sheer size and strength, maybe it is only the more severe and more complicated entanglements, that persist for any length of time for us to report. So hold on to that idea because it comes up in some other places too. Maybe I'll skip a little bit down here to another interesting finding had to do with the multiple trap gear, and that the fact from the final serious injury and mortality rate perspective, those rates were actually quite a bit less than the individual trap fisheries like Dungeness crab and other fixed gear. The primary cause for that is during a lot of those entanglement cases, there was removal and release from gear, which at least helped improve the assessment of that final serious injury. When we look at it from an initial perspective, the rates with multiple trap gear versus single trap gear were pretty similar. There's relatively few cases, only about 12 or 13 of those, if I remember right. And multiple trap gear entanglements also were ones that, occasionally we witness, self-releases by the whale without any human intervention. When we do step back and look at it from an initial serious injury perspective, coastwide for humpback whales with Dungeness crab, the rate would be 0.8. I thought it was really interesting to note that, from an initial serious injury perspective in Oregon and Washington, those serious injury rates are actually quite high compared to California, which circles me back around to kind of wondering, thinking about, the notion of, more severe entanglements persisting for a longer period of time, allowing them to a greater chance to be observed and documented. And when we think about the Pacific Northwest, there are, relatively far fewer, eyes on the water, which may sort of increase the likelihood of a whale going for a longer period of time without being observed, and thus perhaps more severe entanglements being biased. Anyway, that's just sort of a hypothesis for now, something interesting to think about as we move forward. Next slide. So from an impact of human intervention, human intervention occurred in about 20% of these entanglement cases that we looked at. The main take home here is that the removal or release of gear reduces the final serious injury assessment by about 50%. Certainly doesn't take it down to zero. There can be serious injuries and quite often are serious injuries even when gear is removed from whales, but it certainly does help quite a bit. Circling back around to the multiple trap gear, the removal and release rate of gear is particularly high in entanglements with strings of fishing gear. Actually, 62% of those reported cases to us, we've had some removal and release of gear. And I think the most logical explanations for that is, entanglements in multiple trap gear are perhaps far easier to detect. Of course, if you're there to see it. Given that the whale's anchored in place and maybe behaving actually quite weird as opposed to sort of swimming along with just, one piece of gear on it. And having an anchored whale makes it much easier to respond to. It doesn't move around and so you can go back and find it again. And although I'd let responders, probably talk a lot more to that than me, but, it seems like they have a little bit more success in trying to deal with them. Next slide. Okay, last slide here. So sort of circling back around to what can we do with these results? As I say, we know we can provide that information on what we've seen in the past to be used, by the states and for us in terms of moving forward the conservation plans. But there's a couple of more things that I think are interesting. I mean, we see how significant that removal and release, can be, at least from a final serious injury perspective. Jen's presentation's got me thinking about that, which of course obviously begs for increased response capabilities, which brings a whole other level of increased reporting and understanding about how entanglements occur and perhaps how we can not. But I think it also turns us to, hey, if we think there is some benefit from the final injuries, after whales can release from gear, that we should definitely be considering innovations on the gear side that might help facilitate release. Weak links, weak lines, things like that seem like a worthy avenue to pursue. And then finally, the question of switching from the one trap per line sort of system that is common not only in Dungeness crabs but a lot of West Coast fisheries. Could we switch to use of more multiple trap strings? I think there's a good case to be made, from this analysis. If we can reduce the numbers of lines in the water and if that will equal less entanglements, the the expected serious injury mortality from entanglements in multiple trap gear doesn't seem to be significantly higher than what it is with individually trapped gear, at least for those entanglements that are reported to us. And even just in terms of penciling it out, even small strings, I think, offer us an opportunity to potentially reduce, the overall expectations for serious injury and mortality from entanglements. Again, where that may be appropriate. Certainly, if we do pursue that, there are assumptions about those detections and the severity of injuries and some of the questions that I asked that we definitely want to spend some more time further evaluating and monitoring, as we go along. So anyway, with that, I think I will stop.
Great, thanks a lot, Dan. I want to check our chat box and see if there's any clarifying questions for Dan before we go into the panel's discussion. I think there's one we do one for now. And you may have answered this. There was a question: can you define multiple trap gear?
Sure, that's any. I usually call it a string, but anything that's got more than one trap attached to one vertical line going to the surface. I'm not aware of too many short string sort of setups here on the West Coast. We have some fisheries that fish, some relatively longer strings of traps, sablefish, spot prawn, things of that nature. But mostly we have a sort of one trap per one vertical line. Fixed gear pot fisheries here on the West Coast.
Great, thanks, Dan. Not seen any other chat. I guess as moderator, I will maybe ask one question I think that we often get asked, Dan. Just the kind of confirmation process generally. Can you just give like a couple blurb sentences about how you interact with the states and kind of the timing on that, because that's something that we often get asked of industry.
Sure. There's no set timeline for when that happens. It's sort of as information becomes available, as we're able, to sort of gather as our West Coast region team and look at what we've got. But, as soon as we have information, that to us, and we have a fairly set criteria of what constitutes a confirmed entanglement. So, as soon as we've crossed into that threshold of there's a confirmed entanglement, depending on where it is, depending on what documentation that we have in terms about the gear, we'll turn around directly to the states. And if it's an instance of, hey, we see something and, we're just trying to, figure out exactly what type of gear it is, like there's a buoy number or a buoy tag on it or something like that, we turn first, to the states to kind of help us, confirm that if need be, track down the individual fishermen so that, we can have a conversation, to learn a lot more about that gear, when it was set, where it was set, and so forth. And these are live sort of events. We continually learn things, and then there'll be a reciting of a whale, and from a later response, and then that'll cause us to sort of circle back around. And again, I think we're pretty well in touch with all three states at this point, and even with members of the industry through the working groups and other means. We have a pretty large network of folks that we can coordinate with to try to make sense out of entanglement reports that come in.
Great, thanks, Dan. Got just a couple more minutes here before we want to transition. I have a number of questions now, so maybe I'm going to try to pick out a couple here. One, this is from John Kalmakidis. Any sense of why the final determination from NOAA, serious injury determination, matched up worse than the observed survival and the SI scores? And anything planned on how to reconsider those final scores?
No, frankly, that's a new result to me. So obviously thinking about it on the fly. An immediate reaction may be that, in fact, initial serious injury scores are perhaps the best reflection of what we can expect for outcomes. And so perhaps that what happens sort of in that intervening process may not lead to as much benefit as one might see from the current criteria. Again, I think those serious injury criteria are always subject to revision and consideration. And, I think it's actually a process that's ongoing, right now, as it would periodically, regardless. So I anticipate we'll take a hard look, as an agency at a national level at information like that, and see how that may that inform future iterations of the serious injury guidance.
Great, thanks, Dan. I think we've got time for one more, and then we'll transition. Last question here: can you clarify whether a disentanglement changes the number of entanglements attributed to the fishery per that list of fisheries that you guys publish every year?
No, that disentanglement would not. I mean, I will say this relative to the list of fisheries, already relies upon sort of the initial assessments of serious injury for any interaction. Does not factor in a human intervention. So that's been a long-standing process. So yeah, disentanglements that may reduce a serious injury to a non-serious injury. Those wouldn't be factored into the sort of the list of fisheries considerations already.